Okay, so this is day 2 of 8.1 notes, if we can get this actually working. And we will get to that front side. I talked about being on page 10, and you guys are on page 10 finishing things up. And right now, you probably got all this okay. Those are probably all okay. Probably 15 and 16 we don't get, so I'm going to talk about those and make sure. But those are the ones I expect you to know right away. No, we did these yesterday, or didn't I? Did I have you guys do this one yesterday? Ooh, I'm sorry about that. That's my bad. Okay, I had my other classes do 1 through 12. Okay, and perhaps I should have you do that right now, but we're moving. These are straight up perfect squares. Okay, and perhaps that's what we'll do. We'll just get that going like this, and you guys will be able to see what's going on. This list are the first 20 perfect squares. And I always get students asking, Bloom, can I see that list again? Because I didn't get it written down. Dude, it's 1 squared is 1, 2 squared is 4, 3 squared is 9. You mean it's like 4 squared and then is 16 and 5 squared is like 25? I go, yeah. That's all that list is? Yep. The first 20 perfect squares is the first 20 numbers squared, and that's their answer. Okay, so now when you look at this, you should be able to know and maybe look at the list as you're going through what's going on with each one of these. And you should also know that things can't be taken down any further because they're already as far as they can go. That's square root of 3. You can't do anything more with it. So then you got 6, and this one's a trick one. What times itself is 1? You guys are good. You guys are good. I love it. So we got 7, we got 8, we got, oops, this one's done, 9, 11, 12, uh-oh. All of a sudden, this is why we're here. Some people are really good at these, some people are not so good. My job is to try to muster out a idea of how you can get them, but you guys did them as expo students. You did them when you were in algebra as a 9th grader. You did them last year. I mean, it's nothing different. So all I'm asking you to do here is I've got the square root of 9, the square root of 2. I got 3, the square root of 2. Okay, I'm just looking for the largest perfect square factor. Okay, at the largest, it happens to be the only one in 18. Now, couple tricks I use for factoring. Trick 1. If they're even, I divide by 2. Okay? And people are like, that's a good one, Bloom. Everybody knows that. But if I can add the digits, and after I'm dividing by 2 and I'm done with the evens, I add the digits. And if the sum of the digits of the number is divisible by 3 or 9, I go to 3 next. Okay? And then I keep doing that until 3 is exhausted. Since I did 2, 4 is not going to be part of it. It doesn't end in 5, then 5 won't be. And then 6, since I already did 2 and 3, that's covered. 7 is my next one I'll do. I'll try as I work through factoring. I just try to work through the smallest factors on up. Okay? Now, that's one way of doing it, doing a factor tree. Another way of looking at it is cutting the value in half. Okay, after I look at the number and I check my list, is it already a perfect square? 32 is not on my list. Okay, it's between 25 and 36, right? And then I go half of 32. What's half of 32? 16. 16 is on my list. So I could do it that way too. And I noticed that I've got this. So it's 4 the square root of 2 when I go through this. But remember, doing this only really works well if you're really good at factoring. Okay? So as I'm looking at this, I'm looking, oh, I got 300. Ooh, that's 100 times 3. And I know that it's the 100's the biggest one I've got. So that was a nice, easy one. That's 10 the square root of 3. Okay, 169 is on the list. It's 13th. 196 on the list. It's 14th. 98 ain't on the list. It's right before 100. I know it's less than 10 if I put it in my calculator, but I'm looking for, reduced radical form. Okay, which means no decimals. So when I'm doing stuff like this, I take 49 times 2. That one works, that division by 2. Boy, that seems to be a thing that Bloom does. He just doubles perfect squares and makes it look hard. And I triple them too. But this is 7 to the square root of 2. Now, when I keep going on, not all of them can be done like that. And I talked to you about that factoring idea that I do. I'm going to give you an example of what's going on. This is factor trees. Depending on the math teacher you had, you either got shown factor trees and you went on to a different thing, or you stayed with factor trees, okay? And most of them will have that list of perfect squares. They'll tell you, hey, cut the number in half. 224, half of it's 112, okay? And then check all the perfect squares from around 112 up. So at 100, 81, then you'll try 64 into the number that's there. Just find the largest perfect square factor. It's one way, brute force method. Another way of looking at this is factor tree. So factor tree 224, I'm not quite sure why it's so slow. It's coming along quite slowly. 2 and 112. 2 and 56, 2 and 28, 2 and 14, 2 and 7. I have now factored 224. All the factors along this side, and I purposely set it up this way to make my life easier. If I multiply all those up, I will make 224. But remember, a perfect square is an even number of the same factor. 1, 2, 3, 4. Oop, even number of the same factor. That's the square root of 16 and the square root of 14. So it's 4 the square root of 14 when I'm done. Now, how can you check? Well, did I do it right? Grab your trusty steed of a calculator. Settle down, boy. All right, you ready? I know, it's not a horse, but it's kind of fun to think about it because I'm horsing around. But we've got the square root of 224, put it in your calculator. Something less than 15, right? It's like 14%. Whatever you got when you put in the square root of 224, you should get when you put 4 times the square root of 14 in. Should be the exact same value. That's how you know you're right. So check it. Check it right now. Make sure you know what's going on. Are you all okay with that? Because you're just checking me. Did you get like 14.9666 as we're going through? Okay. So that should be the answer for both. 225, 15. 40. Now, I did a factor tree in 21. I did the largest perfect square factors in others. Okay. In 40 is 4 times 10. 4 is a perfect square. 10 is made up of 2 times 5. 2 and 5, not perfect squares, nor is 10. So I know the square root of 4, the square root of 10 is 2 the square root of 10. I'm done. And my last one, the square root of 16, the square root of 10, 4 the square root of 10. I'm done. Okay, are there any questions on reduced radical form or simplest radical form? Okay, now that was on page 10. Our notes today I think are on page 3, so let's get after them. And that's the worksheet for yesterday's assignment. So we got to get to page 3 here. Now, yesterday we went through what makes it right, what makes it acute, what makes it obtuse. Okay, we went through those 3 things. So today what I really need from you is to realize you're going to check. And you will be given questions on the test where, what type of triangle is this? And you, based on your skills, will decide if it's right, acute, obtuse. And we're on page 3. Right, page 3. Right, acute, obtuse. So we're wondering if it's right, that's the rules for right. Acute, those are the rules for acute. Obtuse, right? And by the way, these are the rules to make a triangle at all. And they are all in the same directions right here in your notes. I would totally, if I were you, put an asterisk and put in there, put this information in my note card, okay? Whatever you do to make sure that that gets there, I would put this stuff in there because I guarantee it's going to be helpful, okay? Now, how do we use it? The 2 smallest ones, A and B. Get them done. Go for it. Determine what type of triangle they are. So we got 6 squared plus 8 squared. That's 36 plus 64. That's 100. And then 10 squared is 100. Hey, these are equal. Okay? Because they're equal, it's a right triangle. Now, I'm going to do the same thing in B. 6 squared plus 6 squared is 36 plus 36 is 72. 72 is less than 100, and I have that less than in there for some reason. I forgot to take that out. But because it's less than, this evaluates to be obtuse. Because of the evaluation of being obtuse, please check to make sure the original two values, 6 plus 6 is greater than 10. The two smallest sides sum is greater than the largest side in order to make a triangle at all. And that we learned from chapter 5. Okay, so we're recalling stuff from different chapters to make ourselves successful. Your turn. You got C, you got D, give them a try. Yes, sir. What? No, oh, no, that's all right. You okay? Okay. I just had to make sure, it's watching you. Yes, sir. Oh, yesterday's? I apologize. I thought that's what you're looking for, and I was like, what are you still doing here? Hey, anybody else miss yesterday's class? Any other missers for yesterday's class? We had a couple field trips yesterday. We're okay? All right. So I'm hoping that you got that with those and that you're looking at those two. Are you doing okay? Now remember, the reason why I gave you time isn't so that you could just not do anything. Is so you could practice, and now you're checking your work. Now, if you made a mistake, let's try to correct it on the next couple, but I'm going to do E for you because I always have questions about that. But I need you to make sure you practice this because it's an opportunity to actually work on test questions, quiz questions on your own with no worry about being wrong because, it's notes. I kind of expect you to try, and if you're wrong, we correct it. Okay, so let's check this out. This is the square root of 6, the square root of 8, the square root of 10. That's what these are here. I pop them in. The square root of 6 squared is 6. Square root of 8 squared is 8. Square root of 10 squared is 10. So right there, I've got that. 14 is greater than 10, so I know it's a cube. Okay. Are there any questions regarding this at all? It's the square roots that freak people out. Just treat them, they're just numbers. Okay? So you guys got E, G, and H. Go for it. Finish those bad boys up. At home, you can turn it off, but I'm giving you enough wait time to do it as we're doing it because of the timing here in class. I always forget to turn the board back on, so it's always best to just give you some wait time and get it done at home. Y'all are doing some great work. Awesome. Okay, so let's look at these. I've got 20 squared, 21 squared, 28 squared. Yesterday we learned that 20 squared plus 21 squared was 841, and the square root of that was 29. Okay, so the square root of that's 29, not 28, so these are actually bigger, so it should come out as a cute. Okay, since the legs are actually bigger than C, that comes out as a cute. Now, when we're looking at it being a bigger side, as far as the hypotenuse is concerned, okay, that's where it's obtuse. Well, I've got 36 and 100, that's 136 and 169. This is going to be obtuse, okay? Now we got 5, 6, and 11. 5, 6, and 11. Are they, the two smaller ones, actually going to add to be larger than the longest one here? No. The requirement to make a triangle, keep in mind, it's right up here in our notes, right here. A plus B's got to be bigger than C. Bigger than, not equal to, okay? There's no or equal to on that. So if even if it's exact the same, it's not going to be a triangle. It's just got a couple boards lying on a longer board with no bump up. There isn't any three triangles. There aren't three angles in this. So you got to keep that in mind and how this is going to be applied. But how do I check this? Whenever it evaluates as obtuse, that's my concern that it's not a triangle at all. And yesterday I know I did this in a couple classes. I'm not sure if I did it in yours. What if I give you 0, 1, and 2? Those are my sides. Does it make a triangle? And some people go, boom, you can't have a triangle side that's 0 long. But let's evaluate it. If I square this, and I square this, and I square that, ain't that true? So according to our test, that's obtuse. No way. So we have to interject our thoughts with this and think, okay, 0 plus 1, is that actually bigger than 2? It's not a triangle. But you all surmised that can't be a triangle because 0 isn't a side length. There's no side that has a length of 0 for a triangle. So although it did come out as obtuse, I've got to have another way to look at my check to make sure it makes a triangle at all. And you guys have picked that up. So that's a good thing. All right, so our next thing. We did problem 10. We did not do problem 11. And I'm going to take care of that right here. And problem 10 is very much like problem 11. Okay, so I'm going to start with my square. I've got a square. Hopefully it was better than the last one I put in there. And let's pretend that all the sides are the same and that diagonal is perfect. It's not curved. Okay, I know you guys are really doing a lot of imagineering today for me. But I know this is 9. They tell me that right here. The diagonal length of a square is 9 meters. Okay, I know that it's a square, so all the sides are the same. X squared plus x squared equal 9 squared. Are you okay that a squared plus b squared still equals c squared in a Pythagorean theorem thing for a triangle that's a right triangle? Because it's a square. And remember, a square is a rhombus, and the diagonal splits this into a 45, 45, 45, 45, 90, 2 45, 45, 90 triangles. Well, let's evaluate a little bit. 2x squared is equal to 81. Now, at this point, before I can take the square root of both sides, I must divide by 2. That's a requirement. Everything's got to be away from the variable except, that's the way I've got to look at it. Take the square root of both sides. Now, at this point, I've got to ask myself, is this a final answer or is this a calculation? This is good enough for a calculation. As a final answer, nuh-uh. I've got to make my denominator pretty. I can't have a square root in my denominator. Those are rules with square roots. So this is the same as 9 over the square root of 2. Okay, so now I take this and make it pretty. I multiply by a value of 1. Square root of 2 over the square root of 2 is just 1. So this becomes 9 the square root of 2 all over 2 is my final answer. Now keep in mind, I just did some plastic surgery. I changed the look of the value by multiplying by 1. I didn't change the value at all. It's still the same value, it just looks different. Okay? It allows me to fulfill the requirements not to have the square root in the denominator. Now we did 12 and 13 yesterday. Could you guys do 14 right now as we're cleaning this up to determine what the value would be for the third Pythagorean theorem triple? Remember, for a triple, to be a Pythagorean triple, it's got to be a whole number and work in the Pythagorean theorem. It's got to be a whole number and work in the Pythagorean theorem. Now, as you're working with your calculators today, I'm okay with using cell phones as calculators, but you can't use them as calculators on quizzes or tests. So that really limits the use of them, okay, because of the communication capabilities. And any calculator that has a communication capability, they're starting to come out with those now, you cannot use on a test. I want you to make sure that you purchase something that you can use on ACT, SAT, MCA. If you cannot use those, a calculator on those, it's a worthless purchase. because you need to practice using that calculator. You need to know how to use that calculator and all the really cool ins and outs of it so you're familiar with it. It shouldn't be clunky when you're trying to do something in a test on a new calculator you just got yesterday. Okay, so you should use it throughout your career so that way when you do get to the test, you got the use of that calculator down. Okay, now in this particular problem, I'm looking at 32 squared plus 60 squared, and that's equals c squared. I popped those in my calculator, and I got this in my calculator, and I believe C68. Okay, are you okay with that? Pretty cool, right? That's a Pythagorean triple as we look through, so we're all happy. So yes, for each pair of numbers, find the third whole number such that the three numbers are Pythagorean triples. Totally works. Let's go on to that next question. Last three, I should say. This one is kind of tough for folks. I want to look at this one for day 2 first in problem 16. In problem 16, it's a diagram. Now, I want you to familiarize with yourself with the diagram. Do you see the right triangle? Do you see the hypotenuse of that right triangle? Part of the hypotenuse of the right triangle is 350 kilometers. Okay, 350 kilometers. The other part of that hypotenuse is how long? It's not drawn to scale, by the way. How long is the other part of that? Do you see it? Yeah, what do you got? 6,370 because it's a radius of a circle. And people are like, that's a big circle balloon. What is this? It's Earth. There's a plane flying above Earth, or a spaceship in this case maybe, flying above Earth. Okay, it's 350 kilometers high. Okay, if I'm flying in this craft above Earth and I look out and I see Earth and it's really pretty and I can see as far as the eye can see. So how far would that be if I could see that far? How far can my eye see if I could see that far? I got a Pythagorean theorem problem here, don't I? This is called a tangent line. We're going to learn about that in chapter 12. And at the point of a tangent line in the radius meeting, it's called the point of tangency. We have something called a right triangle, or a right angle. They're perpendicular to each other. So I really have x squared plus 6370 squared equal to, you ready for it, 350, the height my plane or craft is above Earth, plus 6370 all squared. Okay? Now I pop this stuff in my calculator. Start calculating away, finding for x. It's a huge monster number. And one of the reasons why I'm doing this is order of operations for you and your calculator. Because so often I have students assume, oh, if I have a calculator, I'll be fine. And they get the problems like this and they go, ooh, wheels in the bus are falling off, Bloom. How did you do that? So let's check it out. Now, right now, hopefully you have in your calculator $4,581,500, right? And that's squared, so I got to find the square root of that. And you get, after you find the square root, 2140 point, I'm going to round to the nearest penny, 44, hundredth, the hundredth. Yes, dear. Yep, you're right. And I did inside the parentheses, so I add 350. You got the same 54. Did I miss a 1? 5481.
Oh,
okay. Okay, all right. You okay with where I'm going?
Yeah.
Okay. And by the way, I did subtract this from this before I got here. So I took that away. So I just got to the x squared because I did that all in my calculator. You okay with that?
Yeah.
Now, I took the square root of my answer, and because it's kind of there, I can see 2,140.44 kilometers to Earth's horizon. That's assuming that I can see that far. There are things that get in the way. Water droplets, dust, dirt, all sorts of stuff, okay, that prevents me from that. Any good day, visual flight, you got a clear day, it's 10 miles visibility. Okay, that's a pretty awesome day. Well, let's look at 15A, 15B. If you guys would do those two problems right now, and I will hand out today's assignment while you guys are doing that. A math teacher that can't count must be Bloom. You can do two of them, Griff. Your imaginary friend wants to do an assignment? Okay. Okay. How you doing today? You're having a tough day. Here, we'll hand that off to you. Here, I'll take that, man. Okay. All right, so we got that going on. Did you find that this was 207 plus 225? It was actually going to be equal at 432, so it's a right triangle. And did you find that this one, 19 squared plus 18 squared, you put that in your calculator, 27 squared, you found that 27 squared is much bigger, and 19 plus 18 is bigger than 27, so it's obtuse, right? Did you find those as you went through? Now remember, I just did them quick because I wanted to answer your questions, be able to get on with correcting our assignment today. I did not show all the work I would to support my evidentiary stuff because we're here, 8-1B. And those folks at home, I hope things are going well. If you got questions, ask in class. We'll talk to you soon.